This is hello viewers. This is part 2 for the week 5 assignment 5 for the course digital electronic circuits. We have to start from 8th question number 8. If a is equal to some number given, b equal to some number given, these two are two 8-bit signed 2's complement representation. We need to find the multiplication of a and b, and after multiplication we have to find the signed 2's complement representation of the product. So eighth one. So this is part 2 from 8th. So what we'll do is a, this is the given number. This is signed 2's complement of actually minus 6. So the procedure is shown here. And what about b? B is already a positive number. So it's also signed 2's complement form. So it is actually 10. This is decimal 10 and this is minus 6. Decimal minus 6. So we now multiply both these two numbers, a into b. A is minus 6, b is 10. This becomes 60 minus 60 decimal. So this minus 60 now has to be converted in. So we need to find a signed 2's complement. Signed 2's complement of minus 60, and the procedure is same. First find for plus 60. This is binary number, ordinary binary number. Then once take 1's complement, and then finally take 2's complement. So 2's complement will be this one, which is 111 option C. 111 option C. Ninth one. So they have given, this is a 4-bit binary adder. We need to find what is the propagation delay minimum. Need to find minimum propagation delay for getting the results. So full adder takes 75 nanoseconds for the sum, 60 nanoseconds to produce the carry. It is a parallel adder. We will see the solution. So for the first adder, the time taken for S0 is 75 nanoseconds, and for carry it is 60 nanoseconds. And for the second one, so 60 plus 75, it is 135 nanoseconds. What about the carry? The carry is 60 plus 60, it is 120 nanoseconds. For S2, this 120 becomes the delay of carry, and then again add 75 to this one, we will get 195 nanoseconds. What about the carry? So this 120 plus 60, 180 seconds. And for the last adder, so it is 180 plus 75, 255 nanoseconds. And for the carry, it is 180 plus 60, it becomes 240. So minimum, so at least 255 nanoseconds is required to get the full result. That is sum as well as carry. This is not minimum. So we need 255 nanoseconds. So then the number of operations performed is just take the reciprocal of this 255, and we'll get 3.92. 3.92 into 10 power 6, option D. 255 nanoseconds, 3.92 into 10 power 6, option D. Coming to the 10th question, this is they given the decimal number system is 3 and this is 9. So we need to find what is x in for base 9. So the procedure for 9th one. So what I am doing is simply converting base 3 radix base 3 into a decimal number system. Convert this into decimal number system. So once we convert this into decimal number system, and then from the decimal we can obtain for radix 9. So you know the procedure for that one. So what I will get here is 1425, and for fractional part it is a multiplication, and then we consider this 6, and again only consider fractional part, multiply by 9. Again you take this integer part separately, and then multiply the fractional part again by 9. We will get this 2.9. You round off this one, which is equal to 673. So the answer is 1425.673, option B. Option B, 1425.673. 11th one. So here we need to find in which of the following signed addition using 4-bit adder does overflow condition. So what I'll do here is a simple trick is there, very simple. So here, if you add two positive number, if it generates a negative number, then there is a overflow. You take the second case, two positive number add, it is generating a 1 here, because the last one is nothing but a sign bit. 1 indicates negative number, 0 indicates positive number. So this is again an overflow, 1 and 2. And there is no overflow here, because both negative number leads to negative number. And we take another here in this case, this is a negative number, two negative numbers, but it has resulted in a positive number. So this is again an overflow. So answer is option C. Which are that one? 1, serial number 1, 1, 2 and 3. 1 and 2 are compulsory. So answer is option C. 1, 2 and 3. 12th one. So this is the BCD adder. This is the tens complement block. This is the BCD adder block, and then again tens complement block. If the number is negative, after BCD addition, then this will be, then we take tens complement. Otherwise, there is no need for tens complement. So for the given two numbers, we'll try to find what is the output of first block, what is the output of second block, what is the output of third block. So output of first block is, you take tens complement of 38.26. It's simply 100 minus 38.26, which is equal to 61.44. This is the answer. 61.74 is the answer. Okay. And for the second block, what we have to do? We have to do BCD addition. So write 27.25 in BCD, 61.74 in BCD. Add these two number. So if you after adding these two number, so we will get this particular number. So this is mentioned in the problem. So 1, so 0, then 1 0 0 1 0 0. So you can see here. So for these two, 0, 1 0 0 1 0 0 is there. Out of these two, we have to choose which one. So that we'll see. So for the third block, we will take this one. No carry. If it is a no carry, it indicates a negative number. No carry means negative number. Therefore, we have to take 2's complement of this. So I am again rewriting this in the decimal form, which is nothing but 88.99. So take 10's complement. So to find the 10's complement of 88.99, which is nothing but simply finding 100 minus 88.99, which is equal to 11.01. So the answer is option A. This is the answer. Okay. So 61.74 you can see here. So this is 11.01 for third block, and this we saw it is that one. And for the first block it is 61.74. 61.74, this one and this one. This is positive. 13th one, consider a two-level logic implementation of carry look ahead. Okay, a generator. So what we have to find is the number of AND gates and OR gates required for this carry look ahead. We'll see that one. So the question is 13th. So for first carry, input carry, C1, the expression for carry is G0 plus P0 C0. This is one AND gate and one OR gate. One AND gate, one OR gate is required. For C2, it is actually here I am considering. So you can substitute C1 here. So that becomes now here the expanded version becomes. So AND gate 1 AND gate 2, so 2 AND gate, so we need one OR gate for addition of all these three terms, and we need one OR gate. So similarly for C3, so how many AND gates are required? A final expression is here. So AND gate 1, AND gate 2, AND gate 3, so one OR gate, so one OR gate, so 3 AND gate, one OR gate. And for the C4 carry, the final expression is, so AND gate 1, AND gate 2, AND gate 3, or AND gate 1, 2, 3, 4. 4 AND gates are required. Only one OR gate is required. So 4 AND gate, one OR gate. So note down here, very important note given in the problem is all gates, OR gate and AND gates are multiple inputs. Multiple inputs. That is why we are using only on OR gate. Okay. So total number of AND gates is 1 plus 2 plus 3 plus 4 is equal to 10. Total number of OR gates is, so for 4 carries, C1, C2, C3, C1, C2, C3, so that is equal to 4, 10, 4, option C, option C, 10 and 4. 14th, the last question, determine the number of BCD correction required in the following BCD addition. So these two BCD numbers they have given. So how to find the answer for this one? So 984, write this in BCD form, 192 in BCD form, add these two number. So by adding this two number, so look here, for this BCD addition, for this BCD number, that is 8 and 9, there is a carry generated. Because of this carry, I will be adding 6 at this position. For remaining BCD position, it is 0, 0. So that will give me this particular number. So again, what has happened? This particular, after adding these two numbers, that is adding 6, add simply 6. Okay, because why? Carry is generated here because of adding 8 and 9. 8 and 9 carry generated. Okay, then after adding these two, this number is greater than 9, which is not a BCD, Therefore again add 6. Again add 6 here in this position. For remaining position, it is BCD 0, BCD 0. So if we add this one, and then what we get here is this number is 1, this number is 7, this number is 6, and finally carry is 1 for this number. So therefore 176 is the answer. So 2 times we have to add 6. 2, option B. Thank you, viewers. Thanks a lot.